Alright guys, welcome to the channel. We're going to be solving question 30 from the second chapter of the Beer&Johnston textbook, and we have this hydraulic cylinder BC that exerts on member AB a force P along the line BC. So we have this force P here, and we know that the force P has a 600 component perpendicular to the member AB. So if we dissolve this into two components, one perpendicular to AB, we know this one is 600 Newton, and we need to determine the magnitude of the force P, and in the second part, its component along AB. So basically, the question is asking to break this force into two components of one parallel to AB and the other one perpendicular to AB. So I try to draw these forces in this figure, and as we can see, if we define our x and y in this direction, y perpendicular to AB and x parallel, we know in this figure our Py is 600 Newton, which is the perpendicular component to AB. And we have some information about the angles in here. If we can find this angle right here, we can call it maybe alpha. As long as we can find that angle, should be easy enough to find the px and p, because we have that right triangle in here. But let's see how we can find these angles in order to find the alpha. So from the question, we know this angle here is 45 degrees, and also P makes 30 degrees in here. So this one's 30 degrees, and the other side, or the other part of the angle, is also 45 degrees, because we have these two parallel lines, and we have these two. If that one's 45 degrees, this one is 45 degrees too. So if we look at that right triangle that we have, 90 degrees plus our alpha plus 30 degrees plus 45 degrees is equal to 180, which is the sum of all angles in a triangle. So we should be able to find alpha in here, which will be 180 degrees minus 165 degrees. That's going to be 15 degrees. So now it's pretty easy, since we know that P cosine of alpha is going to give us Py, which we know is 600. So our P in here is basically 600 divided by cosine of alpha, which is 15 degrees. So 600 divided by cosine of 15, that's going to be 621.17 Newton. So that was the A part of the question. And the B part is asking for Px, which we know will be P sine of alpha. So our Px in here would be P, which was 621.17 times sine of 15 degrees. And if we calculate this, basically that times sine of 15, our Px in here would be 160.77 Newton, which would be the answer for the B part of the question. So yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions. We're covering 3 different textbooks in this channel. Feel free to check out the playlist. And let me know if you have any specific problem that you want me to solve in the next questions. You guys take care. I'll see you in the next one.